Okay, so the first thing you need to do is get students to draw up the axes of a graph on the edge of an A4 sheet of paper. Make it about half the size of the paper, and then draw in a demand curve from here to here, and dotted lines to cut at the axes of the graph. Then take a pair of scissors and cut along that demand curve line. Okay, so now you're left with a triangular piece of paper with the demand curve on it. The next step is to fold the paper so that each of the intercept points is folded back to the origin of the graph, like this. And fold along there. And then do the other one as well, so that essentially your folding process creates a rectangle like that. And then you can use a pen to mark the midpoint. So it's quite clear from this that this is the midpoint. Perpendicular from this point here to here is the midpoint of this axis, and then the same applies to this axis. So this is now the midpoint M of this axis, and since these are laid side to side, this is quite clearly the midpoint of the graph as well. So then what you can do is draw a dotted line down here to illustrate that. So at this price, this is adjacent to the midpoint, and this is perpendicularly above the midpoint on this graph here. Alright, so the marginal revenue curve is going to extend from here down to here. So this is now demand D equals AR, and this is MR here. The next thing you need to prove is that this marginal revenue curve goes through the midpoint. The way to do that is to first do a bit of algebra and derive the total revenue curve and then the marginal revenue curve from that. And that's not that difficult. As this is drawn here, the function, the demand curve, is the function P is equal to A minus BQ, where B is the slope, dP over dQ, dP over dQ, and A is the value of the intercept when Q is 0. So if you set Q to 0, then you get BQ as 0, and so P is then as A. Okay, so that's the equation for the demand curve or the average revenue curve. Now if we want to derive this curve, which is the total revenue curve with respect to output, then we know that total revenue equals price times quantity which then we can, from this equation here, we can enter A minus B Q, which is price is equal to A minus BQ times Q. And so the total revenue comes a parabola equal to AQ minus BQ squared. That's equals AQ minus BQ squared. And marginal revenue, then this curve here, becomes a derivative of the total revenue curve. So it becomes dTR over dQ equals marginal revenue, which is equal to, we take the derivative of that, it becomes A minus 2 BQ. So what you've shown is that when you compare this equation to this one, this is the average revenue curve, to this one, which is the marginal revenue curve, they're identical except this has twice the slope. So B is the slope of that curve. The marginal revenue curve has exactly the same intercept A, but it has twice the slope. And you can see that when marginal revenue is 0, we know that that signifies the slope of this curve being 0. In other words, at this point. So we've gone and we've derived the equation for the total revenue curve. We know that the marginal revenue measures the slope of that curve, and as we follow the line of the pencil, we can see it's falling corresponding to that till it reaches 0, and then it becomes negative. It slopes downwards, which is of course along here in the negative quadrant of the graph.